Welcome, Hornets, and thank you for joining me today. We're going to be taking a look at how do we use known factors and long division and synthetic division in order to figure out what are the remaining polynomials within factors of a polynomial, excuse me. So we're finding the remaining polynomials of a factor if we are given one. So here you'll notice I have a polynomial in front of me, and this polynomial is just x to the fourth minus 6x cubed plus 12x squared minus 6x minus 5. And I'm going to tell you that 1 plus root 2 is a factor. Now, if I know that this is a factor or a 0 of x, then I need to work with 1 plus or minus root 2. And I'm going to start by setting it equal to x and then working backward so that I can find the trinomial that gave me these solutions. I get x squared minus 2x plus 1 equals 2. I subtract and I get x squared minus 2x minus 1 equals 0. So here we have our first depressed factor. Now, in order to find the remaining roots, I'm going to have to do long division. We're going to divide x squared minus 2x minus 1 into x to the fourth minus 6x cubed plus 12x squared minus 6x minus 5. Now, to do this, we take the front numbers of the inside and the outside, and we put the inside over the outside. That's going to give me x to the fourth over x squared, and my answer is x squared. Put it over the x squared, and now distribute. X squared times x squared is x to the fourth. X squared times negative 2x is minus 2x cubed, and x squared times negative x is minus x squared. We then subtract. This gives me a minus and opposites. This gives me a positive 2x cubed for remaining minus 4x cubed when I add. This gives me a positive x squared for plus 13x squared when I add. Bring down the 6x and the 5. Repeat the process. We now have negative 4x cubed divided by x squared, and my answer is negative 4x. We put the negative 4x right behind the x squared, and we once again distribute minus 4x times x squared for minus 4x cubed, positive 8x squared, and a positive 4x. We distribute our negative. This causes the 4x cubes to cancel, and I'm left with 5x squared minus 10x minus 5 when I bring it down. We're now going to finish with taking the minus 5x squared divided by the x squared, and we get minus 5. Putting our minus 5 up and distributing. Minus, let's see, hang on, that should have been, nope, that's right. I look like I'm about to have an error though, so I want to be careful. Plus 13, positive 5 over positive x. There it is, positive 5. Now we're getting at plus 5, positive 5x squared minus 10x minus 5, distributing our negative. And you'll notice everything cancels, leaving us with 0. Now, we knew this was going to happen. We knew it because we got a 0 as a factor, and we've already identified that it is. Therefore, I can now use this as my second portion of the equation. X squared minus 2x minus 1 multiplied by x squared minus 4x plus 5, and I can now factor. X minus 5, and let's see, can this factor completely? Nope, this isn't going to work. I'm going to have to go through and I'm going to have to find it using the quadratic formula. So here we go. Negative b over 2a plus or minus the square root of b squared minus 4 times 1 times 5 all over 2. I get 2 plus or minus the square root, and you'll notice this gives me negative 4 divided by 2, which gives me 2 plus or minus I root 4 over 2, and that gives me 2 plus or minus I. I now know my roots. My roots have to be the original. 1 plus root 2, then we have 1 minus root 2, and now we have 2 plus I and 2 minus I. Those are the remaining roots that we're working with. Now you'll notice, let's just repeat this again. We started off with our conjugate pair. That's one reason why we knew that had to exist. We then found the polynomial that gave us those two roots, and we set up our long division. The polynomial inside, the depressed equation outside, and when we divide, we get a second depressed equation. We multiply the two depressed equations together. This is what's giving us g of x. Our goal is not to find that. Our goal is to find the zeros. So I took this piece, which does not factor, and I now use the quadratic formula to find the remaining roots. The remaining roots were 2 plus or minus I. Putting it all together, I found the three remaining roots of the quartic polynomial that has a degree of 4. Now you notice, this isn't an easy thing to do. It requires time and effort and patience and practice. A little perseverance can't hurt. Let's try the next one. The next one that we have is p of x equals 3x to the fourth minus 16x cubed plus 24x squared plus 44x minus 39. The root that we are told exists is 3 plus 2i. If 3 plus 2i is a root, we now know that 3 minus 2i must also be a root. We're now going to find the polynomial that gave me these two roots. X equals 3 plus or minus 2i, which means that x minus 3 equals plus or minus 2i, and x minus 3, the quantity squared, is equal to plus or minus 2i, the quantity squared. We do have to be careful. Remember, I squared is negative 1, so the squared gets rid of the plus minus, and I now have minus 4. The other side is x squared minus 6x plus 9. I add 4, and I get x squared minus 6x plus 13. This is now what I have to use with long division. Put the 3x to the fourth minus 16x cubed plus 24x squared plus 44x minus 39 inside of our division. Take the front term, divide by the front term. 3x to the fourth divided by x squared, and I'm looking at 3x squared as the polynomial. We're now going to make sure that we put the 3x squared over the x squared in our division. We're now going to distribute. 3x squared times x squared is 3x to the fourth. 3x squared times negative 6x is minus 18x cubed. 3x squared times 13 is going to give me a positive 39x squared. We're now going to have to distribute our negative and add straight down. These cancel. I have 2x cubed. I get a negative, which gives me minus 15x squared plus 44x minus 39. We now continue with the 2x cubed divided by the x squared to give me 2x. I therefore put positive 2x over the 44x in the division. I now do my distribution. 2x times x squared is the 2x cubed. 2x times negative 6x is negative 12x squared, and 2x times 13x is a positive 26x. We then subtract. This gets rid of the 2x cubes. I'm left with minus 3x squared. I'm going to be left with a positive 18x, and I have my minus 39. Take the negative 3x squared, divide by x squared, and you get a minus 3. We put the minus 3 over the negative 39. We now distribute again. Minus 3x squared, positive 18x, minus 39. We subtract, and we get 0. Remember, we expected to get 0. We have been given the factors, and therefore, by the factor remainder theorem, we know our remainder must be 0 when we divide by factors. No choice. So we're now going to write this as our two depressed equations for p of x. P of x was x squared minus 6x plus 13. That was the first depressed equation from the first two roots, x equaling 3 plus or minus 2i. We have our second polynomial, 3x squared plus 2x minus 3, which we can attempt to factor, or we can use the quadratic formula. Now remember, a quick check with our discriminant. B squared minus 4ac will tell us whether we have imaginary or irrational or rational. Notice we're going to have a 4. We're going to have 3 times 3 is 9 times 4 is 36. And we have a double negative. 36 plus 4 makes 40, and 40 is not a perfect square. We know we have irrational roots. So I'm going to go to the quadratic formula. Negative b over 2a plus or minus the square root of our b squared minus 4ac. Remember, we just did that. That's how we got that positive 40 divided by 2 times 6. Wait a minute, that should be 2 times 3. There we go. B squared. Alrighty, we're now going to simplify it. Negative 1/3 plus or minus the square root of 40 divided by what would appear to be 6. We're now just going to try to finish this by factoring out the 40 and reducing. I get negative 1/3 plus or minus the square root of 10 over 3. And these are going to be my last roots. So I now know that the roots that I have were the original 2, 3 plus 2i, 3 minus 2i, and we now have negative 1/3 plus root 10/3, and we have negative 1/3 minus root 10/3. And these are now my zeros of the polynomial. That's what we're doing in part 2. Let's take a look at one more, because these can be tricky. Let's go ahead and take a look at number 12, or p of x. And p of x is going to equal, let me make sure you can see it, 3x to the 4th minus 16x cubed plus 24x squared plus 44x minus 39. We are told that 3 plus, and I just did that problem. Let me try that again. Excuse me, everybody, as I rewrite the problem. Let's try, here we go. M of x is equal to x to the 4th plus 4x cubed plus 4x minus 1, and the root that we are told is negative 2 plus root 5. That means that negative 2 minus root 5 is also a root. We're now going to go ahead and find the polynomial, the depressed equation that gave us those two roots. Notice I used negative 2 plus or minus root 5. I moved the negative 2 over, so it's x plus 2 plus or minus root 5, and I square both sides. This is giving me x squared plus 4x plus 4, and it equals 5. Subtracting gives me x squared plus 4x minus 1 equals 0. This is now the depressed equation I'm going to use in the long division. We now take x squared plus 4x minus 1, and we divide it into x to the fourth plus 4x cubed, and I'm going to put a placekeeper, 0x squared plus 4x minus 1. I'm now going to take the first inside piece over the outside piece, x to the fourth over x squared, and I get x squared. Distributing, x to the fourth plus 4x cubed minus x squared, and I distribute the negative. The x to the fourth cancels, the 4x cubed cancels, and I'm looking at an x squared plus 4x minus 1. X squared divided by x squared gives me a 1, and I put it over the negative 1. I now go through and I find it as x squared plus 4x minus 1. I subtract and I get 0. I now know that m of x can be factored into two depressed equations, x squared plus 4x minus 1 times x squared plus 1. Since we already know the two roots that gave us x squared plus 4x minus 1, all I need to do is find what are the roots of x squared plus 1. Set it equal to 0, subtract 1, and take the square root. This gives me the absolute value of x equals I. I drop the absolute value, and I get a plus minus I. My answers are negative 2 plus root 5, negative 2 minus root 5, positive I, and negative I. And these are now my zeros that I am looking for in problem number 14. Alrighty, I'm going to leave 16 for you all to try on your own, and we will continue this on Monday. I hope this has helped. If you liked this video and you found it helpful, please click like, and I recommend that you subscribe. Otherwise, please give me comments on how I can improve. Thank you, Hornets. Be kind to each other and be safe, and we will see you soon. Bye-bye now.